Hello, friends. Welcome to our .NET Language and Runtime Community Stand-Up. Today we have a special guest, Bill Wagner, and we will talk about C# Standardization. I guess we start with introductions again. So my name is Immo Landwerth. I'm a PM on the .NET Platform team. And with me today is...
I'm Bill Wagner. I am on the .NET Docs team, primarily working on C#, and a member of the ECMA Standardization Committee that we'll be talking about.
And I'm Kathleen. I work on the .NET team, doing a couple of things, including the .NET CLI and SDK, and I'm also part of the C# LDM, which may be relevant today if we look at how ECMA relates to the way C# moves forward. So it builds on that as well. So, yeah.
Perfect.
I have a question. Can I ask a question? Okay. Remind me what ECMA actually stands for.
I honestly, when I was putting up together the blog post and the announcement for this, I went even to the ECMA site and looked for it. I couldn't find it. I don't know.
I can tell you. It's the European Computer Manufacturing Agency.
Yeah.
No, I don't. Yes, really? That's yeah. So, okay. So we're a substandard to a great big organization. Okay.
Yes.
Got it. Okay. So why do we have a standard? What's ECMA? Why do we have a standard? How did this get started? Does every language have a standard? Tell us about the standard to start with.
Right. Okay. So the standard started with C# 1, where Microsoft submitted C# to ECMA, and then later, once ECMA adopted the standard, we also submitted it to ISO. So it's an ISO standard. A lot of the reasons behind it is when you take a language or take any spec and submit it as a standard to ECMA, there's some provisions that make it an open public standard. For instance, like even if there are things inside C# that are patented or so on, when you submit it to the standard, you cannot charge like exorbitant fees, in their words, for using that patented technology or re-implementing it. So by putting C# as a standard at 1.0, it enabled things in the ecosystem like Mono and so on to implement that standard themselves, right? And that kind of explains part of the history where it sort of fell behind after the C# 2 standard effort. And the committee reformed probably about 5 years ago, started really working again and brought the standard up to C# 5. And of course, in the interim, all of the .NET teams are now working in public in the open. And then we had this standards body that was meeting in private and doing work in private, and then would emerge with a 900-page Word document for a standards body. And we spent some of the time after completing the C# 5 standardization effort and said, well, we would like to work in the open as well. So the standards committee and the secretariat at ECMA worked with the .NET Foundation and said, okay, how can we do this? Let's put the standards work in the .NET Foundation. So now what's happening is the ECMA committee meets, and the weird copyright bit is the drafts are done under the .NET Foundation, and then the committee and the .NET Foundation submit the draft standard to ECMA, which will then, when ECMA votes on it and says, okay, this is now the standard, then the copyright transfers to the standard text to ECMA, and then it's an ECMA standard. And then we'll go on to the next version and work on a new proposed standard for later versions.
Okay. So the major benefit of it came, the original, let me not put it that way. Mm-hmm. The original drivers for it were pre-open source, when external parties wanting to invest in C# in their own spaces needed a confirmation, needed to understand it wasn't going to change, and what was they were going to be able to use it. And Mono is the big winner that we all remember out of that, since it was open source but not Microsoft driven at the time. So now that we're open source, what's the role that the standard plays in an open source world?
In a lot of ways, I think what it does is it puts a lot of rigor in the spec. Okay. In order to, the people on the committee, Mads, of course, is there. Neil Gafter and Eric Lippert, who have history with the C# team, are on the the standard. I do who writes about C#. John Skeet convenes the committee and participates. And then some academic people and some other people, in Rex Jeske, who works a lot with ECMA on different standards, helps make sure that the way we describe everything is very precise.
Okay, cool. Okay, that's great. So it gives people a canonical definition of C#.
Yep.
Okay, great. Okay.
So how is this logically different from the spec that Matt's team is producing? Because when I hear spec, I think, well, there is some sort of textual description that says, here's how C# works, right? And then ECMA presumably writes a similar spec. And are they the same? Are they different? And if they're different, how they're different? And does it mean we now have to make changes to C# in respect to what ECMA is saying?
So we kind of joke about that in the committee, and that we're writing the spec by describing what the implementation does. Which was really hard when we were doing C#5, because we were writing the text to match what the pre-Roslyn compiler did, what the Roslyn compiler did, and the mono compiler, to make sure that all three of those implementations were standards conforming. Now as we're moving more toward Roslyn, we kind of have one reference implementation right now. And it's the purpose of the spec that kind of changes as the text moves along. The Microsoft spec and the spec proposals describe how we want to implement a feature. And they are enough, we talked about the LDM very briefly, introduced that. Those specs are enough to drive the implementation of the feature, and the developers who implement each of those features make decisions as they implement a feature. And then when we take those and we move forward into the spec language, we clean up anything and really describe what the implementers did put down. We describe it in a little bit more precision, in a little bit more of the terms we use in the committee are the normative text, which is these are the rules. And then the informative text, which may be examples or notes that help describe or help you understand what's going on. And kind of the distinction between those is, if we were to remove all the informative text and just keep the normative text, it should completely describe the behavior that must be there.
So can you comment further on what normative text actually means in the context of, I'm assuming that myself and most people listening don't go out and read specs for, that's not what I do on a weekend. I'll admit it, I don't read specs on a weekend. Okay, so can you help us understand a little bit more about what normative actually means in this context?
So like in one of the areas that it's probably going to be really affect as we start working forward is we say what a compiler has to do. So right now there's definite assignment rules in C#, for instance. You cannot access or read from a variable until it has been assigned to. And the compiler has rules that say, well, we can tell if this is or isn't assigned, and here it is. And that code doesn't compile, right? It's an error. You tried to use this before you signed it. We also have, in a few places in the standard, there are warnings that must be omitted by a compiler. Unreachable code must be omitted by a compiler in most instances. When we get to nullable types, we're going to do something similar in C#8, because those warnings are really important to the implementation, right? If you think of nullable reference types, for most warnings, the standard doesn't say anything, right? The compiler can omit warnings, and that's great, but a conforming compiler doesn't have to omit almost any of the warnings. When we get to nullable reference types, we're going to have to say those conditions under which warnings are omitted for, this is initialized to null and it's a non-nullable reference type, or this was dereferenced and it's a nullable reference type, because otherwise that feature won't be that useful. So we are going to have to take the things that Mad spec'd out in his feature spec and said, here's how we're going to implement it. Here's where there's going to be warnings. And those will be rules that a conforming compiler must do.
So when the word normative, is that where the rules are? So that there's rules and there's also explanatory text. Right. And that's what makes up the spec. And the explanatory text is just to make the rules more useful, because if you don't understand the rules, then what good is the whole thing? So the explanatory text is just to help us if we do decide to read it on a weekend.
Right. It will just make it easier to understand the rules in the spec.
Okay. All right. I was just checking the, I'm trying to keep up with the chat at the same time. And Alfred Myers has asked whether there's any plans for a new, that's the one I was going to grab. Yeah. That one's for you.
I honestly don't know if there are plans for Addison Wesley to publish a new edition of the spec with the annotations. I'm not even sure who would know and who would drive that.
Okay.
I think it'd be useful once we reach a point, but I don't know of any plans there right now.
All right. So where would Alfred go to? We like getting feedback everywhere.
I would probably either
Alfred go to say, hey, this was useful. Would you all think about, providing this again? And the second question is, was that book different than the spec?
No, that was the spec. And then there were a number of people. Well, that was one of the specs.
Yeah.
So, and this gets to the standardization process. Once we had C# 3, the Microsoft spec continued to evolve, and there's 3 and 4 and 5, I think, were all printed. And that was the Microsoft proposed draft text that eventually went to ECMA and the committee edited and then turns into the final spec.
Okay.
And, so that was the spec, but it wasn't an ECMA approved standard. So that was the first question. Lost my train of thought. So then what happened? It was the spec, and then any number of people who worked either on the CLR or wrote books about the CLR or .NET or C# were asked to provide commentary on the spec in terms of some of the behavior we've either found interesting or really important to understand.
Yeah.
And hence, it's the annotated C# language.
So it would be kind of cool if that was all electronic now, but I also wonder whether it would really be that interesting to Alfred and others, because we haven't really talked about it yet, but it's been implied that the ECMA spec is behind, and it is partially behind by design and partially behind by history. Correct? Or is that the wrong view of the landscape there?
No, I think that's a good view. I think part of that is the standard will always lag a little bit behind the implementation. We'd like to get a whole lot closer.
So what are you working on now? Which one are you working on right now?
We are working on both 6 and 7. So what we have done in the C# lang repo and .NET/C# lang, where the language design team meets, we had the Microsoft 6 spec, and we took the changes from that and we're merging them into the standard to produce a version 6 standard. In parallel, also because we just want to learn how we're going to work in this new way in the open, we've got PRs on a branch for version 7 or 7.3 that takes the feature specs from versions 7, 7.1, 2, and 3 and makes those changes to the C# standard as well. So we've got PRs on about half of those features. So we're hoping that working in the open helps us catch up a little bit more quickly.
All right. Okay. So working in the open, does that mean that it's an open source effort that people can help with, or does that just mean people can watch?
People can help. And there's an interesting little bit of ECMA thing there, in that to be on the committee, to be one of the committee members, you have to be nominated, and the people in charge of the committee and the convener have to agree that this is an expert who should participate. Okay. So all that means for us working in the open means if anyone submits a PR to changing some of the spec language or helping us refine it when they find an error, that just means one of us on the committee will have to review the pull request and merge it. And then effectively the committee saying, one of the experts, we were told this was an error. We took the feedback and the fix and we put it in place. So yes, we are happy to have PRs on anything that would help us fix the standard and help it improve and help us move faster.
So one question I had is so my mental model of this ECMA spec, and you should tell me when I'm wrong because it's just my mental model, is that basically the way Matt's team works is that the spec they're producing is usually a difference, right? As in C# works however it works today, and so the spec that they're producing is basically describing the new feature as an addition, rather than the ECMA spec, which is kind of like, if you start from scratch, here's all the rules of the language. They take a more, after you take these deltas that basically Matt's team produces and you incorporate them into the document. So when you go to the type section, now it enumerates all different kinds of types and rules, rather than, oh, here's one section for this area, here's another section for this area, and you have to kind of compose this entirety thing in your head. Is that a kind of an accurate statement?
Yeah, that really is. And there's a bit of history there too. And this also explains part of where the specs diverged. Is if you go back to the spec and the standard for C# 1 and C# 2, especially C# 2, if you read it, it was, here's everything that's in C# 1, and here's a couple chapters that tell you what's new. And Mads in particular did a tremendous amount of work when we got to C# 3, where we took all those features and everything from generics and all of that and turned it into one cohesive document that says, here's C# as of version 3. Well, now the two specs had converged, and a lot of the work that we did for 5 was to take the divergence of those two specs and rearrange and move everything so that now the standard matches the work Mads had done in 3, and then all the features that were added since then, and was a very cohesive look at C# 5. And in 6, we started with the draft spec that was in C# Lang, merged those changes in. So that was pretty straightforward, once again, because it was in the same order. As we're working on 7, as you say, Immo, we're taking these deltas of, these are the rules that change, these are the new features that are added, and we're putting them in the right spots, which helps us with reviewing. It makes it a little bit easier to review it feature by feature. These rules change here, and then expressions here and here, and there's a new type here, and so on. And that's really the work that we're doing now.
Yeah. So let me just clarify a couple of things for anyone who might not just jump on these. So if you go to C# Lang, you'll find a spec, and the spec is for 6. Okay. And we are now on 9. That was released last November, and 10 is in planning. So 7 is the one that came out with 7.1, 7.2, 7.3, and ECMA's going to treat that as one, correct? They're not going to try to split that up?
Right. Here's and this is something the committee is still deciding and discussing. So our working plan right now is that we're going to do the work more or less in version order: 6, the family of 7, 8, and 9, because that gives us the option to say at any one of those checkpoints, we can submit a document to ECMA and have them vote on it. Okay. Because the voting takes time and they may come back with requested changes and so on, we are trying to balance. We'd like to catch up to 9 as quickly as we can, and pausing for voting and feedback cycles slows that up a bit. So right now, one proposal that we're currently debating is the next ECMA spec would be 7.3. And the reason for that is it pulls in all of 6 and 7 stuff, and it is the last version that runs on framework, since that would be C# 7.3.
Yeah, that would be, yeah.
And then hit 8 and 9. And hopefully if we can do that fast enough, then maybe we do both 8 and 9. Hard to say. And at this point, it kind of depends on how quickly we get things merged and get to a draft we're happy with.
Right.
How quickly we then want to take that from ECMA to get voted on.
Yeah.
And then there's a separate process if we wanted to take the ECMA spec and then also send it off to ISO to be an ISO standard as well.
So it's super challenging for you all right now, because with C# updating every year and updating with significant new features. So let's remember, if you're back on 6 and 7, introduced the beginning of pattern matching. So we've got to start at that, but there's a whole new conceptual thing. And then in 8, we introduced this whole new conceptual thing, a couple of things there. So we have no reference types coming in at 8, and correct me if I get these numbers wrong. And that's where we got ref structs in as well, correct?
The ref structs, I think, came in 7.
Oh, did they? Okay. So there's these big things that must be hard.
Yeah.
Even if you've got the baseline to work from. You've only just to hold in space. You only have a year to get a version through the entire process. And if you're any slower than that, you're falling further behind, and you have to actually be faster than that in order to actually catch up. So it's a huge. I see it as a huge challenge for you all, and I'm very impressed that you're. I'm very impressed with the whole process because wow, that's a lot to accomplish in a year.
So there's also something where the LDM team is really helping us now, and I think we're going to be able to accelerate our pace as well. In that, I think 6 and 7 are going to be some of the hardest ones, because at that point in time when those were being worked on, the ECMA committee wasn't even meeting, and it was unclear if we were going to keep standardizing going forward, right? And if you look at the proposal documents for those are probably the least rigorous. If you start to look at 8, and especially once you get to 9, when we were meeting regularly, if you look at the proposal specs, they kind of say, here's the grammar rules that change. Here's the rules that change in expressions. Here's what changes in statements, and so on. So it's going to be, it's almost a recipe for us to pull those in. Okay. So I'm hoping that as we get closer to where we're at now, the documents we're starting from make it easier to get those rules correct and to get them correct faster.
Good. Yeah, I know the team cares a lot about trying to get this information recorded well. And if you know the right places to look and the right people to ask, you can find out more in, short of the spec. So if there's something you want to know about C# 9, there are places you can go. But it is not as clean as a spec, which, Immo, I don't know if you can scroll back to it and find it. You're faster than I am at that. We had a question, which I thought was a really good question, back up, that was, how does it make sense for, here, I found it. Yeah, you read my mind. I didn't even actually complete a sentence anywhere there. And you found the one you wanted. So I think it's a super good question. Thank you, Jonathan. One.NET left may not be quite the way I would put it, but yes, in a world of one.NET where Mono, which was the major other, C# is, incorporated in this new world. I can imagine some benefits of the spec, but from your perspective and the people that are pouring time into this, what's the reason to keep doing it?
Well, it saves me a lot of time, for one, and here's why. So, since I'm responsible for the C# docs on docs.microsoft.com, I'm writing the things that help people use this. And one of the things that I find, especially going through the language reference area and related sections, is that it's almost grabbed text out of the older specs and put them in place as to what, how different, statements and expressions work. And that's like two or three places where we describe the same feature and they get out of date. So by having one document, we say, this is the full thing. One of the things I'm doing in the language reference area is I'm making it noticeably smaller so you can get a good feel for each feature, but it doesn't have the same depth as the spec does, because I'll just point to the spec. And it also does help with the rigor. It firms up any of those things that maybe wasn't specified as tight as we might want in the proposal documents. And then we find, okay, this has to work this way. So then, once the implementation is done, then we can describe it a little bit more clearly. The rigor of the people who on the committee are, some of the academicians and some of the people who really specialize in writing the standard is helping us create noticeably better language to describe a feature in terms of just really, really being clear. So that helps as well. I think those are probably the biggest benefits overall.
I would add that, I'll use it, especially around, thinking about new features in LDM, and I'll be like, So what is the overload? And also because I am the Visual Basic PM, and so there's times when it's like, okay, I need to explain a little bit more about the difference, say, in overloads between Visual Basic and C#. And there is a canonical place to go see the C# overloads. VB doesn't have a similar spec, so there it's more experiment, see what the behavior is, because that's VB is what it is. And so the spec is helpful to be able to say, hey, I can tell you how C# handles overloads in presence of inheritance, because it is quite different than VB and quite unexpected for some people. And so I like the idea of the docs giving you what you need, but then not trying to give you everything, because man, sometimes you just go in there and your head would start spinning over some issue that wasn't important to you when you were trying to get a big picture. So I really like that. So the point you're making is it's a canonical place, but I have to challenge you a little bit on that and ask how that relates to the fact the spec is old. I think I have the answer to this, but I want to talk about it, which is you're telling me that the docs is based on a 4-year-old spec, because right now you're actually, you're working with drafts maybe, are you working with the release spec? Are you going back to 6? So talk about how this, do features just never change? Is ultimately, I guess, what question.
So that is part of it, and I do have it easier than some of the people who work on other features in that there is such a high backwards compatibility bar in C# or in VB, right?
Right.
If I have a C# 1.0 program, it compiles and it works.
Right.
So some of those features, as we say, they don't change. Some of the rules change. One of the ones that I was getting issues on because it was, I didn't even see it, is because VB had this feature. There were issues I'd get where, oh no, exception filters do work in C#. And I'm like, I didn't know we said they didn't, but if you go back to the old documents, they did. And so that definitely helps there to bring some of that forward.
Okay.
We do on docs right now as a stopgap measure, we're publishing the LDM specs for features up through 9 because
Right.
it does help. We know it doesn't have the rigor, but it's better than not having anything while we catch up. And toward that 1.net, I think that gets to a lot of it. You're going to start seeing more of the tools. I saw the one question on the Mac, Visual Studio Mac go by. I know that team is working on updating the compiler to use more parts of Roslyn and fewer parts of the mono builds. And I think that's getting close to completion, but that's not my area exactly. So I wouldn't want to misquote it, but we should see more things there too.
So Immo, do you want to catch up on some of these questions people are asking? So we've got one about, actually I can do this, can't I? I have power. Can I do this? No, yep. I didn't do this. So that wasn't what I meant to do. I meant to do this one. I'm so sorry. I go back to the options question. Yeah. So I don't want you to necessarily go deep into this specifically, but I do want to tell you, the reason I want to bring this up is that we're on docs, you're here, we might as well, tell people what to do. What should somebody do if they go to a page and they say, this doesn't have what I need? What's their next? They have a couple options right now. What should they do?
Oh, right. Okay. At the bottom of any docs page, you
want to show it actually?
Yeah, let's show it.
Let me just let's do it.
Window. Let's actually just look and see where I can find exactly that page. So you want to configure a weight.
I know. Let's do. Yeah, you want to do this one?
So if we hit there and there we go. So if we look at any of our pages that aren't on API ref, but are rather in our conceptual section. Here we go. So we'll start with that one. And if I go to the bottom of any of the pages that you're seeing and you're not finding what you want, this part right here on the feedback control, if I hit feedback for this page, it's going to take me to GitHub just to create an issue for this page. And inner title, inner stuff here. This helps us figure out what document it was on. and
So
who's
just don't
responsible
touch
for that
that.
part.
Just leave
Yeah.
all that stuff in
Just
place.
leave that.
Okay.
And when you do that, especially if you don't find something, if you don't find what you want, what really helps us is what you searched for to get to the page you're on. Because often what we'll say is, oh, that's documented over here.
But you
And
didn't
if we
find
know
it.
why you ended up on the page that doesn't have what you want, we have a better idea how to get you to the right page, maybe improving some of our SEO, or at the very least getting the links correct to get it to the right place.
Okay. What if they know the answer? What if there's a typo they find, or there's something that they really believe they know how to fix? Should they just put it in that issue, or should they do something different?
There's something better there is if you want to fix anything, if you find something that really needs fixing, if you click the edit button, that's also going to take you to GitHub and take you directly to the source. And then there, if you click the pencil again, now you're editing the file directly in GitHub. If you found a typo, go ahead and just fix it. And then at the bottom of the page, it's going to say, you can write your message here saying, fix the typo, you spelled something incorrectly, what have you. And then go ahead and commit the change. And that'll be a PR that we'll review and, probably merge. Most of the time, we probably merge close to half a dozen to a dozen PRs from customers every day. And they are usually small things. What I would say as part of this discussion is if you find something that you think is a big change or something you really want to discuss, make an issue to save yourself time and let's have the discussion first.
Yeah.
If you find something small, hey, you misspelled this word, just make the PR, because the PR probably describes the change better than an issue, where in the fourth paragraph and the third sentence. Right. So save both of us time.
Yeah, and if it's a typo or a grammar fix, you don't even need to worry about having much comments in the PR. You guys are going to see the diff, and you're going to go, "Oops," and fix it. So that's awesome. I'm sorry, I saw that go past, and I was like, I really want folks to see this. So this one we should answer really quick because we can. I'm sorry, no. We still think about it. We still think about it. I assume you mean options as in a functional language sense of something could be some or none, and we think about it. We may wind up adding it, but it is not currently. We currently do not have a spec for that. It is a challenging problem for .NET because as strongly typed as .NET is, there are actually several ways to implement what you mean by that. So is it an enhancement of enum or is it an enhancement of inheritance? And so the way that I'm thinking about the problem right now in terms of design is exactly that. So do you want some or none with a common parent class so that they can exchange with each other? And language support to make that work well? Or do you want a choice? So more like enums that have extra features attached, enums that can have properties. So that would be not an enum, but a typish thing that would sit under an enum-ish thing, and something like that. And so there's still a lot of thinking because the constraints of a typed language do drive the C# language quite a bit, or any language that's sitting on such a strongly typed platform. In the same way that a language on a different platform is driven by its constraints. And this is one where we're still working on what the basic shape ought to be. So I don't know if Bill has anything to add to that.
Nope. I think that was a pretty good description of it.
So one question I have is, like, you mentioned that before we went live, but there's basically two big ECMA specs, right? One is C#, and one of them is what we call the CLI, the Common Language Infrastructure, which is effectively .NET as a runtime concept with the metadata format, the actual runtime semantics. And so now, as we are evolving the language, we are very often pairing that with runtime features, right? So the ref structs come to mind here, or some of the stuff we're doing with default interface members, or now with statics and interfaces in the next version. How does that interact? So, like, my understanding is right now there's not a working group really actively evolving the CLI spec. So how does it work in the C# ECMA spec when you have to kind of implicitly describe or depend on runtime behaviors?
Well, here I can show you. If we go back to the screen share. So right here, I'm in the spec repo, .NET C# Standard, and our README now has the full table of contents for the entire spec. And if we go down here to the appendix, we've kind of finessed it for the moment. And if we look at the standard library, what we do have is we split it into two sections where we've said here is basically everything that's from the last time we reference the ISO spec here, but for the last time the ECMA spec for the common language infrastructure was updated. These are the types that were defined there that the C# language formally depends on. And then we have a second appendix where we say, these are the types that aren't in that spec yet, but the language does depend on. So things like caller file attributes, expression types were not in the last approved ECMA spec, all of the task awaiter and so on. And we'll continue to keep adding these here. The language spec formally doesn't say anything about what or how the runtime does anything it does. So we kind of get to finesse that and go, yeah, there's something that makes, say, default interface members work. When we get to that, we don't have to say what the mechanism is, or like ref structs. We kind of define what the language rules are as to what a ref struct is going to be, which we're nailing down right now. And then we just leave it. Something makes that happen.
Cool.
That makes sense. But are we doing anything with the runtime spec, or is there nothing going on right now?
Not right now. That committee would need a convener, and then we would need people who know that area well enough to really drive speccing it correctly. I know the only things I kind of know is a little bit about what C# relates to. I certainly would not be the kind of person who could drive that spec correctly. So we'd probably need input from people who live at that level of what the CLI and what the runtime does.
Yeah. So you just took us to C# Standard. Okay.
Yeah.
So I am curious about the relationship between all these pieces we're talking about. So we mentioned C# Lang. This is C# Standard. We've got the Roslyn compiler sitting out there. We talked a little bit about the relationship with CLI, which is good, and how that works out. But I think all these pieces we've talked about, but maybe you could just kind of make sure that we're thinking of them, how they fit together in a good way.
Yeah, I think that's a great question. And I think it also really helps for anybody who wants to participate in any of these places to go to the right place more quickly. Yeah. .NET/C#Lang is where innovation on C# happens. That's the language design team. Kathleen mentioned she's on it. I listen in on those meetings and occasionally speak up if something's going to be hard to explain. But, that's where innovation happens. So if you have an idea for a new feature or a new way something in C# should work, that's where that conversation starts. And Mads and Jared have talked quite a bit about how you make the proposal, find an LDM champion, have the discussions, and work through that process. And that's how it gets implemented. .NET/Roslyn is the C# and VB compilers and the tooling that kind of relates to that model, like some of the analyzers and some of the libraries that work with analyzers are in that repo. So that's the implementation, the reference implementation. C# Standard is where we describe what's already been shipped. So if you have an idea for something new in C#, don't come to C# Standard, go to C# Lang. If you find something in the spec language that doesn't make sense, come here to C# Standard, not to C# Lang. Found a bug in the compiler? You probably didn't, because, that's just the way that usually works. But then you would go to Roslyn.
All right. And then
I love that. I think Jared told me once when somebody files a compiler issue, there's kind of two categories. There's the one person that says, this is definitely a compiler bug, and this is never a compiler bug. And then there's this person that says, I'm probably doing something wrong. There's a super weird thing that happens, and then, yep, that's probably a compiler bug.
Well, as long as I've been using C#, which is like early alphas 1.0, I have actually found one, and it wasn't a pre-release. Yeah, that's pretty much it.
All right, I'm just answering something in the chat at the same time, so I'm typing at the same time. Yeah. So the other thing about C# Lang is if you haven't, if you want to see what's going on, the meetings notes are there, so you can keep up with what is happening with that. We talked about that on, Matt's talked about that last month. That's not on the show. Yeah, I'm sorry, too many videos in my head right now. So yeah, it was on this show last month. Matt's talked about the process. So if you're interested in that, go back and watch this show last month. And we had a lot of fun with Matt. It was a really good show. I really like that one. I like you too. This is a great show too. So I'm sorry, Bill.
Okay.
All right. So that was awesome. So Amos, what's come to your mind, or what's in the chat, or what?
Yeah, so the chat is a bit derailing into configure await details now, which I think are slightly off topic.
I
I'll
was
address
trying
that.
to drill the docs. Okay, my fault.
Actually, I can talk about that one real briefly, and this is something that we know, and I really am hoping I get some time between now and C# 10 to really address. One of the really nice things about docs being in the open is that it's really easy for me to look at areas that generate a lot of questions and a lot of issues. And what is really clear to me is we haven't explained the task-based asynchronous protocol, async and await, and configure await really well. I spent like 3 months just tagging all those issues and putting them in a project. I absolutely understand that that's an area that we don't do extremely well. I think there's, it is a tricky thing to get right and explain well. And I've been taking a lot of notes as to how we want to explain that and really do a better job than we do. In the meantime, a plug for one of our MVPs, Stephen Cleary has a really, really good book that's published by O'Reilly called, I think it's like Async, Await, or Task-Based Cookbook.
I think it's
the title correct, Kathleen?
It was concurrency. I put Stephen Cleary's name because it's a Stephen, so you have to worry if it's a PH or V. So I put Stephen Cleary's name and what I thought I thought it was concurrency in C#, but maybe he's done 2 books, or maybe that's so it would be. I definitely would put a plug in for that book, but a book, it's like, oh my gosh, I want to do async and await. Do I have to read a book first? And so yes, this is a hard thing to teach. I will tell you, as somebody who has tried to teach it and not happy with the teaching I've done. Have taught it with Bill, who I think does a better job of teaching it than I do. I have a tendency to move really fast in my teaching, and async is really something you need to kind of slow down, pick it up, look at it deeply, and understand what you're doing and understand what async actually means. There's a lot of bad async code out there that's actually slowing programs down, and we haven't found the right way to do analyzers to find them yet. But we're not done teaching async and await, and so I think you're right when you point to that as something that needs better stuff. There's lots written about it, and certainly Stephen Cleary's work. There is a Stephen Tobe blog post that is.
Yeah, and that's actually something.
It is the mind reading, and except he didn't use that word. Yeah. It's mind reading debugging for, but it's not the word mind reading. It's not clairvoyant.
Debugging, probably.
I think so.
Psychic. Thank you. Psychic debugging. And this is a really old blog post, but it's really good. Psychic debugging. Async. Stephen Tobe. Who's another Stephen STEPH. Stephen Tobe. TOUE. He has an old blog post that's actually still really good from early on about rules that are helpful to follow.
And that's in fact some of what we're going to do. Stephen Tobe also has the white paper out that is a really good starter set. Right. And then a number of his blog posts cover it very well, but they're spread over like 3 or 4 years. So they're hard to find and consume in one place. So we're going to kind of reorganize that and then add other things to hopefully make it a little bit easier to understand, easier to work with.
Yeah, I really like when I thought about the way you're doing the C# language and with the docs referencing out to other things. I was thinking for async in a way that's really good too, where at one level it's like, here's some rules to follow, here's some things to think about, this is what you need to know, here's the minimum set. But there's an awful lot deeper that a lot of people are going to know. And configure weight came up, and we said nothing about what it actually does. And that's just one example of these deeper levels that you sometimes need to get down to in order to use async well. And so I'm really excited to see what you do with it. I'm sorry you haven't had a chance to get to it. I know you have a million things on your plate. And then but that is definitely, it's great to call us out for that one, because it's a hard thing to learn, and we have not yet made that easy. I think, by the way, you kicked it out of the park. You did a fantastic job with the pattern matching stuff. So, I think that this isn't, like the opposite, where we haven't found our legs to really do a good job with async, even though it's quite old and there's just a whole lot of pages written on it if you go out and look for it. But pattern matching, the docs are really good on pattern matching.
And I will add like maybe 30 seconds more on helping people consume some of the things on async and await and task-based stuff. Is you'll find very different recommendations for whether you're doing UI-based, client-based programming and server-side programming, because your goals are really different. In the UI, you want that responsiveness. You don't want the UI thread blocked. Server side, it's a totally different thing. You want as much throughput, and you want to be able to scale better. So you don't want threads not doing work. So there's different goals, and that's why you'll find some really conflicting recommendations. That's also what we're trying to figure out. How do we reconcile those and say, yes, I know we said this over here, but we're saying this over there, and there's a reason.
Yeah. I think that's good.
One question that was in the chat, which I think is interesting, like it's kind of a general problem that we have all up, is like, do you see the possibility of obsolete features to be removed from the language and specs at some point in the future? It's something that we all struggle with. Like, we all know how to add. It's very hard to ever remove. So how do you think about that?
Yeah.
Here I'll probably parrot Mads mostly here. But then I'll add some of the things we're trying to do in docs for this. At the moment, there are no plans to say that a feature in C# won't compile in the future or won't run the same way in the future. That is not saying never, but it is saying, I really don't see it. I'm not sure what we'd remove. Now, that said, there's a really interesting problem that I have in terms of explaining C# now and helping people use the C# that is today. So the question that I asked that I try to really put into a lot of our docs is, what is the subset of C# that someone should start learning if their first experiences with C# 9?
Yeah.
Okay. And we kind of mentioned this in terms of the spec. It's almost natural for someone who's been here for a long time to start with the way we used to do things and then introduce new features because they feel more advanced. And that's not really what's true. Something like, say, top level statements, I would start day one with that because it's got less ceremony to try and explain all the ceremony we had with a namespace and a class and the static main, void, args, this and that, right? So I would start with top level statements and then move on and introduce each one of those concepts at the right time.
Right.
So that's one thing that I'm really trying to do, is try to get to this point of, here's the subset everybody needs. And then here's things you're going to see because they were the way we did things before. Yeah. And then there's also, here's things that you're only going to need in certain scenarios. We touched briefly a little bit on ref struct or span. And I think we're all going to be consuming those APIs because they do make the framework a lot faster, but I don't see a lot of developers outside of the runtime team creating and declaring new ref structs.
Right.
Or function pointers, which were just added. I don't see that getting used by a lot of people, but it will have a big impact from the few people who do use it.
Right. Well, the follow-up question on that I want to go to, because I think it's really good. And where I want to go with this is that there are some features that I think we'd all agree just don't use this. So one example these are all older ones I'm thinking of, array list. I don't know of a single reason you would use array list today, but I don't know if that's marked in the docs. And I don't know if we have an analyzer that just says, yeah, just don't. There are some things that we might consider lessening the way they appear to you. So, in the CLI, we look at pulling things from help. So that's the way we tell you it's obsolete. We can't break scripts. So that's something we might consider in the future, and analyzers that kind of guide you away from that. Because I think, in that space, who on earth today is going to remember or care about the bizarre problem with the Turkish I that led to invariant, to upper invariant versus what was the other one, to upper ignore case or something? I don't remember what the other one was because I just now always use invariant. And so how is somebody who wasn't there, who lived through, oh my gosh, we have to change the way this works and it will break people, so we're going to make up a new name. If you weren't there living through that, why on earth would you have any idea why we have two things that do almost exactly the same behavior?
I think one area I would look at there, you were talking kind of about API reference and some APIs.
Yeah. I did slide into that. Right.
And from a language level, the other feature that I would watch is warning waves, which is something that you can see an example of kind of the first pass at warning waves with nullable reference types, where I can turn, even though I'm using C#, if I don't enable nullable reference types, you're in a nullable oblivious context. You have to turn the feature on. And you can also turn on just the warnings, or you can turn off the warnings if you want. And that's the kind of thing that may happen to drive people toward newer features instead of using the older ones. There's some talk of, do we use warning waves to say, don't use this anymore, even though it will still work? And that's an interesting question. I don't think it's been resolved. I don't think there's a proposal yet, but there's certainly some discussions on it.
Yeah, that makes a lot of sense. And I'm sorry that I did. I just slid straight away from languages. And languages are one of the most stable aspects of most platforms. It's easy to say except, and it's just that everybody else learned what pain it was to a community to have the major breaking changes when Python did that. Everyone else gets to not do that. We will not do that because we saw what happened. And so, what I'm trying to do is be very kind to Python in that, because it's not like a community had ever tried that before Python did, and it caused it was just a mess in the community, even still today. And so I think that you can count on a lot of stability and language features that you just shouldn't use anymore. That's harder to come up with, really.
Mm-hmm. And I think there is something about, and this is why there's such a high bar. If, let's say, C# 10 came out and programs written before C# 4 stopped compiling, that would be a huge friction for some people to adopt it, because in order to adopt it, you have to fix these things. And that's probably not, the fear is, the legitimate fear is, instead of, people would just upgrade and fix those things, they just stop upgrading. And that's probably a bigger problem.
Yeah, small things can change. There's we talked about something. I haven't looked at the meeting notes. I'm sure it made it into the meeting notes about ways to do some possible changes to literal strings that would have an impact on some people. Some things do change. So and if you're interested in that, go back and look at meetings last week for. I think it's going to have literal strings in the summary of it. But things do change, but they're subtle changes. They're not like, don't use this feature anymore changes. They're like, this behaves differently than it used to. And we don't do them very often, except for overloads. Overloads are always being refined, it seems. And you generally don't get into the space where they're being refined unless you're doing funk of something or blah, 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 and you're in these really complicated cases. And then there's refinements, but they're almost always just taking things that wouldn't compile and allowing them to compile. So there are changes, and but we work really hard.
But and that's one that we don't consider that, while it's a breaking spec change, it's not a breaking change in that no one's using the code that couldn't compile.
Yeah.
So one question that came up in chat, which is kind of an extension over this whole obsoleting stuff, is this one here. Are there ideas of creating a new .NET language that combines, quote unquote, the best elements of all .NET languages?
I'm trying not to say my flippant answer, but I don't know of one right now.
I thought that's F sharp.
There's nothing in progress. I think that, and this is what I've said when I various times on language panels and stuff, I'll get asked questions about, what would you do? What would be the next big step? Things like this. I answer the same thing here, which is I think today the most exciting things going on in languages is the polyglot work. And for .NET in our land, what that is .NET Interactive. So .NET Interactive is not just polyglot like VB C Sharp. It's polyglot like C Sharp SQL or C Sharp Python. And so it allows you to use the different platforms together. So
and C Sharp JavaScript.
Yeah, so there's like 8 things you can go in, and they're adding more all the time. And so what you can do there is go in and from the same space access the platform. So you can go in and access the platform for .NET and do what you want to do in C Sharp. And then you can go in and actually access SQL as a platform or Python as a platform, or the many things mostly through Python that are available in a IPNYB, it's a Jupyter Notebook format, but it's in .NET Interactive, which is different than Jupyter Notebooks. We have a couple notebook things going on. I apologize for that, but .NET Interactive and .NET Notebooks allow you to use languages together, and not just like different dialects together, but fundamentally different languages. F Sharp's in there as well, if you're an F Sharp fan. And I think that is the next thing in languages, is probably going to be that space where through, Notebooks has shown us how powerful that is. And then how can we take that, and I believe in 2 or 3 years, we're going to probably have executable, and maybe even 6 months. Okay, we're going to have executable things that can do that. So you can have not just a notebook interactive experience that's bouncing into different platforms quite comfortably, but even an executable experience that can do that. So, there's some amazing things that you can do with some of the tools that are available that come out of the data science world, but apply that to your own debugging. So take your debugging logs, run them through ML type stuff, data analysis type stuff, and come up with suggestions. So I think that it is truly amazing. And being able to see things graphically, being able to see your memory graphically with these high-end tools is just amazing. And so I think that's what's going to come next. Not a new language, not that we have run out of all the language ideas in the world, but that we have kind of centered in on, if you make the assumptions, strongly typed, very large framework that does a whole lot for you. A couple of these other base, this is what C Sharp is about, and VB and F Sharp. This is what they're about. Within that space, we've got pretty darn good languages. If you go to the space of not strongly typed and dynamic languages like JavaScript, well, we've got a pretty good story to lay over on top of that some control of your types with something like TypeScript. So we've come really far in these once you take your base set of assumptions, within that base set of assumptions, what's a really good language? And I think we've gotten pretty far on that right now. Mm-hmm. So I don't expect to see a new language. And across .NET, I think we'd be challenged to do more than we are right now with the great things going on with, I think, C Sharp, VB, and F Sharp each have their own reasons to use them, their own benefits, and they're just a little bit different as you figure out which one works best for you. Mm-hmm. And the follow-up language, I think, on a question on that, is that the easy to extend the language? Yeah, I worked in a language, it was Clipper. I don't know if anybody did Clipper, but Clipper was a fully extensible language. We didn't call it that. We call it like code blocks or something. But we used to extend our language all the time, and it was kind of amazing. But I'm not sure I'm ready to do that again because the resulting code could be quite non-maintainable. So it was a lot of fun, but I don't know. Well, what you got, Immo?
I think that's pretty much it. And I think we are at time anyway, so I think we could call it a day.
Yeah, there's one thing we didn't cover. Can we do one more quick thing?
Of course.
Which is, I'm not sure I got completely straight what the relationship was. You mentioned the .NET Foundation, and you mentioned ECMA, but I'm not sure you quite clarified. I don't recall. I can't bring to mind how they relate to each other. I did get how ECMA exists and how ISO exists and how your work feeds into that. I got that part, but I didn't get where .NET Foundation fits in.
It provided the best vehicle for us to do all our work in public.
Okay, great. Okay, so that's the copyright is actually an important thing. You mentioned that in passing, but I didn't register that as being actually a key issue.
Yeah. So what that means for us, so once it's a standard, it's an ECMA copyright. Okay. So in order to do the work in public, we needed some vehicle where we could work in public under some foundation to be able to say, all right, this is all covered. We're doing the right CLA licensing and so on. And then the committee can take all of this from the .NET Foundation and submit it to ECMA as a spec. So it's mostly about dotting the I's and crossing the T's for that. And leveraging the .NET Foundation ecosystem as a whole, just in terms of providing a good home for a project.
Okay. All right. Okay, super. All right. So, Immo, you want to wrap this up? The clock on the wall says we went over again.
Standards are fun.
Standards are fun. Yeah. Thanks, everybody, for being with us.
I think the only thing that keeps coming back is, like, I think you need to talk about T4 at some point, Kathleen. Like it is a recurring theme in the show.
So I would love to talk about generators again. I talked a little bit about source generators. I'd love to sort source generation out today for people because T4 is got. I'd be happy to talk about T4. Not much has happened in T4 for quite a while since we got. So yeah, we can do that. Let's plan for it. It's not cutting edge for us right now, but we can talk about that and talk about how it contrasts with source generation, because those two things are quite different and they each have their own niche. And I don't think source generation is necessarily going to make T4 go away.
Sounds great.
Yeah, you don't love T4.
Source generate all the things.
Do that.
I just like source generators better.
You like seeing me react, that's all.
I just like source generators better, that's all.
Oh, source generators are freaking amazing, but we've talked about them. We can talk about them again. We should get Jared on. We should get Jared to come on with source generators and also cover T4 in part of that talk. That'll be an awesome section.
I think source generators are awesome. The biggest problem with source generators is that it's very hard to actually have them part of your project. You basically have to do unnatural acts today to have a secondary project with the source generator. You can reference its source, but it doesn't quite work in the IDE, right? I think that the nice thing with T4 was it's just a file in your project and magic happens, and it's just a very low barrier of entry compared to source generation.
This is absolutely true. And so the so T4 was I just want to do something in my own project, this little thing. I'm gonna tweak it as I go, and it's absolutely what it's set up to do. Source generators are much more, I know what I'm going to do over and over again across different projects, and I'm willing to make a pretty significant investment, particularly hugs to everybody who's been working on source generators so far, because the experience for authors was not the first thing that was developed. And so getting access to it was a problem at first. We've got that solved in the latest builds. The latest public builds have access to the output. Look underneath where you do your references, go underneath, find your generator, and then expand your generator, and what it generated will be sitting underneath it. So that's how you actually find what's generated. But that's not debugging yet. And so debugging is one of the things that's being worked on. I would tell you it's being worked on. People are aware that, yeah, it's painful. So everybody's ever written a source generator today, lots of hugs. It's really hard, and it's just going to be getting better for that. But the problem of whether or not they're going to wind up in inside projects, they may. That may happen. And then the other thing people ask about all the time there is, let me change my code. And I'm afraid the answer to that remains no. We need people to believe in the code they wrote, and having the code you write change after you write. If you want to do that, use PostSharp, use something that does post-processing, and great, do that. That's fine if you want to do that. But the niche that source generators hold is that we will not change your code. And if we ever changed that commitment, we would be very loud about it. I do not expect us to do it. The niche is that you know what code you wrote, it's still written that way. What you call may not have existed at that point and may be created for you, but you will have access to that code to look at it. And that's the commitment that we have around source generators, which I think is the right commitment for C#.
It's also relatively new. So like what some person asked, like, are regexes using source generators? So like my team is actively looking into basically expanding what we do today with reflection and reflection emit at runtime to build time using source generators. The problem that we run into is that getting the user experience to a point where we are happy with the result is actually quite hard. And part of the reason is what Kathleen said, is that one of the key deliberate limitations is that you can't change code the developer wrote. So you basically have to find sensible entry points that the developer can either apply an attribute on something, or a partial method, or a partial type, where we get to generate some other thing on the side that the user then can call into. And that's not necessarily very clear cut on how this will look like. And so just yesterday, we spent a lot of time, actually 2 days ago, we spent a lot of time talking about source generation for JSON serialization. We have thought about regex source serialization, source generation as well. And it's something that there's not really a treaded path. I think, as far as I can tell, we are one of the only languages that has this capability in that particular form, where basically expose the compiler to a tool that you can mess with. And so we are still figuring out what the ideal user experience is for this space. And I feel like once we have that for the platform layer, I think it's probably also easier to just open this up a little bit more for the application developer, for these domain-specific parts of your code, where you just want basically a loop around some code that emits it multiple times rather than you typing it in, which is basically what T4 was really good at. But I think we're not there yet. I think there's like all the other things we have done recently, like code fixers and analyzers. This is something that is pretty well established in the ecosystem for like a decade, right? Eclipse had it, IntelliJ had it, ReSharper had it. So there was a very common understanding of what the user experience should be, versus this stuff is kind of, we're treading a path that we haven't really treaded before. So we need to figure out what looks good, what feels good, what creates confidence, right? But everybody agrees we don't want dialects, right? So we don't want some developers that can inject their own new keywords, their own new language syntax, or rewrite methods or stuff, because then you look at your code, you're trying to debug something, and you can't trust a single line of code anymore because something is happening somewhere, right? And so nobody likes to live in that world. It's all great when it works, but we need to keep in mind that 80% of our time is spent in the debugger. So we want to look at code and reason about it, right?
Yeah. Which somebody asked earlier about languages. That's another space. Somebody might come up with a sane way to do a language which was largely dialect-based. So you wrote your own dialect and then you scripted your program. So that might happen. I haven't seen it yet, but folks played in that space. And I think that could be something actually new that actually could be interesting. Yeah. We got way off on generation over time. Anybody who's stuck with us, thanks so much. Generation's interesting. We should come back to it. Let's see if we can get that on the agenda maybe for next month. We can't commit because if we don't get the right people here, then it won't go well. But we definitely appreciate any input you have. If some of our talks go better than others, we've been focusing on guests lately because we can focus on it closely on a topic with an expert, and we've been enjoying that a lot. And Bill, thanks. You're awesome coming to. And Bill, by the way, came on slightly short notice. One thing we have not yet gotten good at is planning ahead enough. We can warn you more than 3 days in advance what our topic's going to be. And Immo is looking guilty there. I think we can. Everybody.
To me, 3 days in advance is orders of magnitude better than what it used to be when 5 minutes before we wing it. Like I mean, I take
And
more.
I think our shows are better because of it too.
Mhm.
So.
I mean, the one thing I thought about generation that might be useful is like if we could get somebody from my team to do a deep dive on how we do one of our generators to get a sense for how this plugs in and what the challenges are. I think that might be an interesting topic to cover.
That would.
Right
Yeah,
now, it's a bit early because we're still struggling with it, but I feel like once we have a better picture, I think it would be good to do that.
And Rosalind's looking at some changes that are coming. So I don't know how deep we want people understanding the generators. I think it's super important, and at least a high level. Jared has a great short demo that we've done on on.net. There's an on.net show, by the way, that I've done with Jared, so you can find that. It's a 15-minute quick overview. But teaching people actually how to do a complex generator today, when some of that's going to change in the future, maybe .NET 6. I'm not sure exactly where that work is slated for, but the folks there are definitely have identified key problems and are working on it. And so hopefully we're going to see that soon. But we can get folks on. We can talk about the state of things. We can see if we want to go super deep or get Chris and, like having your team do a demo, or get Jared and Chris on and talk about, why we did it, what it does, why we're not going to do change your code in place. We're going to just do additive stuff. How you do additive stuff. What does it mean? How do you design around additive stuff? I think that's super interesting. It's interesting to me. I have a generator that's a prototype of something I'm trying to do with system command line. It's actually, when it works pretty well. Unfortunately, I don't spend enough time on it to keep it working well, because it's like every third weekend, not like a regular thing for me. So, yeah.
Makes sense. Then I think it's time for us to wrap up. Like somebody in chat asked earlier when we are back, our schedule is every 4 weeks. So we have this .NET community stand-up where we basically rotate through like 4 different areas. So that basically means every single show, I think there's one for Xamarin and one for, I forgot, there's like 4 of them basically that cycle. ASP.NET is on a different schedule. So, but basically we are back every Thursday, every 4 weeks. That's basically
right.
the
So let's just be super clear on that. Every Thursday in this time slot, there is a .NET community stand-up. So every Thursday there is one. We are one of 4 that rotate. And so we will see you in 4 weeks. That's Immo and I and Rich and Phillip often join us. So.
Alrighty, then I think it's time for us to click on the thank you for watching link, and then we say bye-bye until next time.
Bye now.